Hello and welcome to COP 4708. In this session we are going to address data and databases. We are going to define them, and we are going to go over data before and after technology advancement, see the difference between these two periods of time, and then the structure of a database, and then database management systems, the different database management system that we might see or experience, and available database jobs that will lead us at the end of the semester, or maybe two courses, to land into one of these jobs, and the definition of metadata, or description of data. So what is data? To understand database, we need to define data, and data are values that can result from measurements as numbers, or could be words or images, which means that we can define data as values of quantitative, those are the numbers, and qualitative variables that are the text or words, or the images could be qualitative. With the digital age and the different devices that we have, data points are increasing. So if you take a data point by itself, it would not have a meaning. For example, if you take 72, the number 72 by itself, it doesn't provide any information. Once we add to that number additional data points or additional information, organize them in a certain way, we will have a meaningful let's say expression, or something that expresses this number, the 72. It might be 72 degrees Celsius, that is for Orlando or for Daytona Beach, Saturday at 12 noon. So now by adding these other data items or data points, we are identifying that the number 72 refers to the temperature in certain area at a certain time at a certain day. That's how we define the data, and we organize it in a way to be meaningful for us. All businesses actually keep data, whether names, addresses, phone numbers, products, dates, sales, transactions, and many other things that companies and businesses are collecting every day. And those data points are, as we said before, are increasing and increasing. If you look at the data before, you will see that in the past, data was stored on paper or index cards or any other forms of material that can hold data. With the increasing number of data points, dealing with the data became harder and harder. Piles of paper, headache, and always there is a need for help. With the data now, it's being digitized, and it's stored in text files, spreadsheets, and you can arrange them even in files. So that will make them very efficient, easy to store, and easy to retrieve. It is more convenient and more cost effective. So when we put a structure around the data, which means organize it in a meaningful way, we will create what's called a database. The purpose of the structure is to help people track things of interest. As we stated before, numbers, images, words, letters, characters, whatever you name it, it can be organized in a certain way that will be meaningful and can provide certain information. And the information later on can be used to derive knowledge. That is the purpose of the whole organization of the data. The data in a spreadsheet is considered a database. This database or this spreadsheet has a specific way of organizing the data. And if you have the understanding on how to use spreadsheets, you can move very quickly within the data and find the information that you are looking for. In addition, you can add data points, records, columns, and you can delete or manipulate or change whatever data points you have in that spreadsheet. So if you look at the database structure or how it's laid out, you can see that the data is structured by being stored in tables. And tables are objects that store data in rows. So this is the table. Then I have rows that are called record or instance, and columns that are called fields or attributes. So tables has rows, and sometimes you will hear people saying record instead of row. It's the same. Or columns, that is called fields. So whether fields or columns, they are the same. Those are the naming conventions that we will go or we will use over the semester. So you have to know exactly what does it mean when we say field. Field means column, attribute means column. So field or attribute or column are the same meaning, which means column are the same meaning. Record, instance, and row are the same meaning. And all of these are structured in one component that's called table. That's called a table. A database may have one table or multiple connected table, as we can see in the figure here, where each table stores data about a different thing. So we can store data about student in a table, and then about the courses that they are taking in another table, and then the faculty that are teaching these courses in a third table, and so on. So we can store the data in different tables, then link them together to make a meaningful database structure. This is what's called a relational database. Relational database because it has a relation and it can lead from one table to another. The relation between these tables can be one-to-one, one-to-many, or many-to-one, or many-to-many. One-to-one, one or one-to-many, exactly the same as an example of one faculty advisor advises many students. So one-to-many. And many-to-many is many students taking many courses. And a course has many students. Although spreadsheets plays a very important role in storing data points, when it comes to managing and manipulating the data, it has limitations. And the limitation has been stated in another session. In addition, we might find the same record repeated again and again without the ability to recognize such a problem. And there is a need to secure some data points at a certain time. If I'm dealing with a spreadsheet that has patient information, that has social security information, that has other important information, then at a certain point I need to lock it and make it password, user ID and password protected. That's why there is a need to what's called a database management system that can create, process, administer the database, and a system that can be secured, that have security capabilities. Those systems such as Microsoft Access, MySQL, SQL Server, DB2, and Oracle. The main component of a database system is an database application or interface. The database management system itself, which is the part that creates, processes, and administers the database, and the database repository or warehouse. Those are the three parts or the three main components of a database management system. So if we start looking at the different database management systems, starting from Microsoft Access, which is considered as a low-end product intended for individual users and small work groups. Microsoft Access uses an interface to hide much of the underlying database technology from users. It's a good strategy for beginners, but not for database professionals. Microsoft Access is a database management system plus an application generator. As a database management system, it creates, processes, and administers Microsoft Access databases. As an application, it generates queries, forms, and reports components. Although it is popular and easy to use, easy to structure, the data that's been used, it falls apart when you need a lot or lots of people to access it at the same time. Because of this kind of limitation of Microsoft Access, database administrator searched for multi-user database management system with client-server architecture that can provide a multi-user capability with the ability to keep the integrity and consistency of data. One of the database management system that is also popular is MySQL or MySQL. And SQL or SQL refers to Structured Query Language, which is an internationally recognized standard database language that is used by all commercial database management systems. MySQL is an open source database management system that's popular and can be obtained for free. It is supported by Oracle. Although it is a step better than Microsoft Access, it still lacks lots of functionalities such as triggers, stored procedures, cursor support, and full join capabilities. In addition, it has limited import-export capabilities. So we'll go to the next step, which is SQL Server. And SQL Server, it has, it has been there for a long time. And the latest 4 or 5 of them is 2005, 2008, 2010, and 2012 SQL servers. So all of them almost the same capabilities with additional functionalities and tools and more efficient capabilities. So for SQL Server is a client server multi-user database management system that has special mechanism to control user concurrency. Now notice that when you are talking about multi-user, that means multi people will be accessing the same record at the same time, and you would like to make sure that the changes will be correct, especially if 2 people are accessing the same record and changing in it, and that's what's called the integrity of the database. SQL Server has integrated comprehensive analysis and reporting capabilities, which enhance decision making. In addition, it has lots of functionalities such as triggers, stored procedures, cursor support, and full join capabilities. And you will know about these terms later on, either this semester or in the next semester, where we go in details in 4709 with database management using SQL Server. The best about SQL Server that it doesn't have limitation in the import-export capabilities. So you can import from Excel, you can import from CSV files, from text file, any kind of file. It doesn't have any limitation actually on the import, and it can export to different database management systems. It has built-in features that protect your data against unauthorized access and many other features. The DB2 Enterprise Server Edition, or any edition actually, is meant for high-end mainframes and may have some difficulty working on lower-end computer for smaller database needs. The GUI interface tools are fairly limited when compared with other database management systems, and it's not compatible with any of the .NET products from Microsoft. That's why lots of developers would not like to work with DB2 and would prefer to work with SQL Server rather than DB2, which was developed by IBM. The last database management system is Oracle, and it's a high-end multi-user database management system that will support multi-operating systems. It has a full application platform that does not only manage the data, but also analyze it and create the proper reports needed for proper decision making. Oracle has an improved query performance, scalability, and it's easy to maintain. And it has minimum application downtime. Although it's comparable with SQL Server, but SQL Server is more of like a medium to large companies, while Oracle more or for global enterprise or large enterprises that has lots of branches and extreme, let's say, size of databases. If you compare all database management system with the power and the features and the difficulty that they have, you can see that Microsoft Access is the least. Then I would say that MySQL is in this area, then Microsoft SQL Server, DB2, and at the high end is Oracle database management system with the highest power, lots of features, but it needs more of a professional developer to deal with the development of the backbone database. So what are the jobs? Why do we study databases? There are lots of jobs that's related to database and database management, such as database programmers with medium pay, and that's a study that was done in 2010 of around 71,000 per year. That's $34, almost $34 per hour. That's for a database programmer. Then we have database designers. Also, the database designers is around 70,000 annual salary. And then database administrators, also based on the study that was done 2010, it's around 73,000 annual salary. Then we have database developers, we have desktop support. So all kind of jobs, starting from the desktop support all the way to the backbone designer and developer. Although database is stored in tables, we can create an interface that can collect and store the data, such as forms, or an interface that can view certain data, such as queries, or an interface that can report for us the different data points that's required or specific data points. So we are using forms, queries, and reports to actually get the information in and out from the database. A database is a self-describing collection of integrated tables. We said that we have either one table or more than one table, a few tables that's related to each other, or hundreds of tables that are related to each other in what's called relational database. And if you look at those integrated data tables, you can see that the information between the data is related, and you can actually get information from one table that supports the information of another table. For example, as we said, if we are talking about student name, ID, address, and so on. So if we have the student ID, I can get the information about the courses that they are taking. And from the courses, I can get the name of the faculty that's teaching that course, and so on. So a database is called a self-describing because it stores a description of itself. And the self-describing data is called metadata, which is data about the data. And you will see what I mean by that in this slide. So in the first table above here, you can see that I created a table to show what kind of tables do I have in the database. So I have 1, 2, 3 tables. Table that's called student, a table that's called class or course, a table that's called grade. And then I have 3 columns in the student, I have 4 columns in the class, and I have 3 columns in the grade. Then the key that will open each table can be specified in this one. The second example here, or the second table of metadata, is the user column table, which lists all the columns that I have in the database and to which table does it belong, and the data type for that column, and the size for that column. So all that is called a self-describing database that is being held in this backbone table that is called metadata. That will be all for this session. If you have any question, you can either email it to me, or you can call or Skype, or use any of the proper channels that's been provided online. Thank you and have a great day.